Okay, this is going to be our second video for polynomial division. Okay, in our first video, we looked at the process of long division on polynomials, and of course, that process could get very long and very tedious with a lot of writing involved in it. So, the process we're going to look at in this video is known as synthetic division, and this is a simpler process that you can use when you're dividing a polynomial by a binomial. Okay, but it can't just be any binomial. The divisor has to be a binomial of this format, 1x plus c, where the coefficient on x is 1 and the power on x is 1. So that has to be a linear binomial with a coefficient of 1 on x, okay? So this first example is perfect for synthetic division. Notice my divisor follows that format where the coefficient on x is 1 and the power is 1. Okay, so here's the process. First thing you're going to do is take that divisor, set it equal to 0, and solve for x. Okay, you're going to take that result of -1 and you're going to put it in what I like to refer to as the box. Okay, so this number is going into the box. And then to the right of the box, you're going to write your coefficients from the dividend. So that would be 3, -6, -2, 1, and -6. Then you're going to put a plus sign followed by a long line there. And now you start the process of synthetic division. To begin, you'll bring this first number down. Okay, write it below the line. Now you take that number, you multiply it by the number that's in the box. So 3 times -1 is, of course, -3, and you're going to write the result here. Now you're going to add up -3 with the number above it. -3 plus -6 is -9, and now the process starts over. Take -9, multiply it by the number in the box of -1, result goes here. 9 plus -2 is 7. Then I take 7, I multiply it by -1 from the box, I get -7. 1 plus -7 is -6. -6 times the -1 in the box is +6. -6 plus 6 gives me 0. And I always like to put in front of that last value, I always put a few dashed lines to represent the fact that this last number is always my remainder. Okay. All right, so we're seeing that everything divides evenly here. All right, so now we focus on these four values. The 3, -9, 7, and -6, they give us the coefficients on our quotient, okay? And what we have to reason out is the powers on the variables that correspond to each of these coefficients, okay? So think about it. If your divisor is x plus 1, where x is to the first power, and then your dividend, it has a highest power of 4 in it. When you perform that division process, the resulting quotient should have a highest power of 3, right? So that means that this 3 right here would be the coefficient of x to the third power. So we have 3x cubed, okay? Then the -9 would be a coefficient for x squared. The 7 would be a coefficient for x, and then the -6 is your constant. Okay, so there's your quotient. All right, let's do a second example. All right, so notice the divisor here is again x plus 1, which means this is perfect for synthetic division. I take that divisor, set it equal to 0. X equals -1. That's the number that I put in the box. Okay, now notice my dividend. 5x cubed plus x squared minus 7. You see how we're missing a linear term where the power on x is 1 in between x squared and -7. So that means we're going to need a placeholder, okay? So To the right of the box, I write 5, 1, then a 0 before I write -7. So this 0 is my placeholder. Okay. Then we give a plus sign, long line, and now we start the process here. So bring the 5 down. 5 times the -1 in the box is -5. 1 plus -5 is -4. -4 times -1 from the box is 4. 0 plus 4 is 4. 4 times -1 is, of course, -4. -7 plus -4 gives me -11 for my remainder. Okay, so for my quotient, I was taking a cubic polynomial, dividing it by a linear polynomial, so the resulting quotient should have a highest power of 2. So it's going to be 5x squared minus 4x plus 4, and then taking the remainder into account, I'm going to subtract 11 over my divisor of x plus 1. Okay. All right, one more example. All right, in this example, look at your divisor. Your divisor is 3x plus 2. So this coefficient of 3 is an issue. We want the leading coefficient to be 1 in order to use synthetic division. Okay. Now that doesn't mean we can't use it, because at least we still have x being raised to the first power here. It's just I have to account for that 3 first before I can use synthetic division. How I account for it is I simply divide both the divisor and the dividend by 3, and I rewrite the problem. Okay, so that's going to lead me to 2x cubed minus 5/3 x squared minus 4x minus 5/3 divided by x plus 2/3. Okay, now I take the new divisor of x plus 2/3, I set it equal to 0, x ends up equaling -2/3, and that's the number that I would put in my box. To the right of the box are my coefficients, 2, -5/3, -4, and -5/3 again, and a plus sign. Okay, let's bring that 2 down. 2 times -2/3 is -4/3. If I add -4/3 with -5/3, initially that gives me -9/3, which reduces to -3. -3 times -2/3 would be +2. -4 plus 2 is -2. And then -2 times -2/3 would be 4/3. Okay, -5/3 plus 4/3 is, of course, -1/3. All right. So now I can formulate my quotient. I took a polynomial whose highest power is 3, divided it by a binomial whose highest power is 1. So my quotient's highest power is going to be 2. So this means I'd have 2x squared minus 3x minus 2. And then here's where you got to be careful. We're going to do subtraction by 1/3 over the divisor of x plus 2/3. Okay, but I don't want to leave it like that. All right, I don't like the fractions within fractions here. So recall my very first step in this whole process was up here dividing by 3. So I'm going to undo that original step, and down here I'm going to multiply this fraction by 3/3 now. So in the beginning of the problem, I divided by 3. At the end, very last step, I will multiply by 3. Okay, and you only have to do it to the fraction of 1/3 over x plus 2/3. All right, make sure when you do this, you distribute the 3 into that denominator. So that's going to lead me to 2x squared Let's use blue here. 2x squared minus 3x minus 2 minus, now 1/3 times 3 would just be 1, and x plus 2/3 times 3 would give me 3x plus 2. So this is what we want to consider our final quotient. Okay. All right, now it's your turn. Pause the video, work on the practice problem there, and then when you're done, check your work with mine.